Hello, I'm Paul Swiatkowski. I want to take you through my final project, basically looking at the correlations between what's happening in the Arctic as far as the sea ice melt and what's happening in the lower 48. Um, People are talking about it. It's getting to be big news. Um, there's a lot of people who don't pay attention, but in the last week we had a number of articles appear in some digital press. Fact of the matter is, the Earth's defenses are getting blasted. The Arctic ice shields us from a lot of the radiation from the sun, and with that gone, it hits the water and warms up. It's not a good situation. There's one thing that I'm talking about in the link on this page, if you get there, is amplification. And you'll see that there are so many ways this is a very disturbing impact. So one of the ideas I'm trying to look at is, yeah, this is happening. We're losing our protective shield, and we're getting all this warm water. The hypothesis is that all this moisture is hitting the United States, and what I'm planning on looking at is the linkages between what's happening in terms of sea ice loss and what's happening in terms of several key meteorological variables. The work on this has been equivocal. There's never been any real clear evidence that the Arctic is influencing the mid-latitude weather, but they do open the door in their very highly regarded research effort that, yeah, let's keep an eye on it. So that's where I'm going. My work derives directly from this. So what did I do? I took a look at weather stats being collected by the National Center for Environmental Information. I looked at the sea ice being collected by the National Snow and Ice Data Center. And I looked at drought indices being collected by the drought people. And I put together in Hex a variety of Python manipulations and ultimately distilled them down into some spreadsheets and some data frames that looked at essentially a monthly view for each of the seas and for their impacts in each of the various reporting areas. We have one which is the NCEI and the other one which is from the NINIS. Okay, so what does this look like? This is from the NCEI. I'm able to collect from each of these reporting stations. They have some 33,000 or something. And I looked at these variables. You see the variables have air temperature, winds, clouds, and precipitation. On the sea front, we look at the various seas that are available, and you can see the ones I put in red dots over here: Bering, East Siberian, Chukchi, Beaufort, Canadian Archipelago, and the Hudson. Those are the areas that I've looked at with the greatest attention. Some of these where I have the don't sign were maybe downwind from where we are, and also, at least in the case of the Arctic, Central Arctic, had a data anomaly, which I had to take out because when I was looking at this time series, this was something that would have followed up our measures. These are the seas I did look at, and you'll see here that they're very standard and regular and looks very good. Here's something worth note is the sea ice in each of those areas of consideration all have declined dramatically. This is in the terms of the percent the greatest sea ice loss ever. So here we are. You can see all of the seas have lost double digit, almost 20 and 30%. One of the ways of looking at sea ice and sea ice loss is to think about this baseline period, 1980 to 89. These are the monthly averages of the sea ice actual coverage. And you'll see that, one of the preferences here is to get rid of that. That's not really what we want to see. We want to see what happens when I get rid of that average. And so I created a series called sea ice differences, and those look at what is the difference between what was observed and what was the baseline. So it will be a minus when I have a bigger baseline. This is what it looks like in March. You see these baseline have really tamped out the variation. This is all synced to 0. But in September, you can see that there's a dramatic decline. The other and last data set that I looked at was brought to you by Drought.gov, and they had this moderate drought metric called D1, which measures pretty much 1+ standard deviations less precipitation in an area. And you can choose the area and actually create selection across multiple areas. So I did that. I did it in the following framework. I collected Pacific Northwest, Northwest Rockies, Southwest, and so on. That's what it looks like when you run the tool. You're able to generate the data, and out comes data that I can put into the correlations. So first of all, a little basic refresher on correlations. I've got monthly sea ice here generating this negative decline. The expectation is that my actual variable going into this is going to be on the declining side, which will be minus. Over here on the metric side, if I have a bigger than baseline temperature, let's say, this will be positive. I'm going to get a negative correlation. So we go through this little tricky interpretation, but simply put, less ice, lower, less metric. The first analysis I looked at here was for these areas across the individual seas. And I chose to do the individual seas because we get some nice redundancy in measurement. And one of the most rewarding things is when you get a lot of confirming evidence. And that's what we have here. We're seeing a lot of negative signs up here in the Northwest and Southwest. So what did we say? Well, we said lower ice, higher temperature. So we're getting higher temperatures in the Northwest and everywhere else pretty much, but maybe not causally dictated by these westernmost seas, but definitely by the seas, let's say the Canadian Archipelago and the Hudson. Yeah, those are close to where we are in some of these more central kinds of locations. Oddly enough, we found the opposite is true, is that when the Bering is losing a lot of ice, we're seeing lower temperatures. And that might be, again, because the moisture is just heavier and it's creating a cooler air. So this is a fabulous finding. I did not expect it to be quite so terrific. And what does it look like on a map like this? You see a lot of sun coming here. You see a little bit of cooling here with the Bering Sea. I also looked at average wind speed. Remarkable. What we're seeing here, I never would have expected. We're seeing unanimous confirmation that positive correlation, meaning lower sea ice, lower monthly average wind speed. So we're getting lower than benchmark in a very statistically significant manner. Similarly, total sunshine for the period is a very strong negative, or meaning that the sun is increasing, the sun is actually decreasing. So we have low sea ice, lower sunshine, positive correlations. We have a smattering here on precipitation, interestingly, not a lot except in the southeast, lower ice, higher precipitation. Interesting. So maybe this is carrying forward. And lastly, we get some snow. Here was, I think, when you look at the bigger picture, here are the conclusions I came to. We also use that drought index. The drought index talked about 1+ standard deviation above and below average. And what we find here is positive correlations, meaning we're going to see lower sea ice and lower precipitation in the plain states. I'm sorry, less drought. This is less drought. And what we're finding is it's rainier. We also find the same to be true when you talk about the negative correlations here with the wetness index, meaning less sea ice, more wetness. These are the many related weather impacts that are being cataloged. I hope that given where I've been in the study, I put together a couple caveats. One, there's a lot to be done here. We can certainly look at some of the relationships in a lot more detail. And caveat two, I feel pretty good about this, and I'm going to keep at it.